All right, in these notes today, we're going to take a look at the Pythagorean theorem, which is a very well-known theorem in geometry dealing with the side lengths of right triangles. So the Pythagorean theorem says that the sum of the squares of the legs of a right triangle, which is a triangle with a right 90-degree angle, that's 90 degrees, equals the square of the hypotenuse. So if you look at a right triangle, you have two legs, which are the two sides that make the 90-degree angle. And then you have the third side, which is called the hypotenuse. And so the Pythagorean theorem says that if you square or add up the squares of the legs, it equals the square of the hypotenuse. So a squared plus b squared equals c squared, which is probably something you've heard before, even if you haven't used it. And so what we can do is use this formula to find missing side lengths of right triangles if we know two of them. So the steps to do this, just use the formula a squared plus b squared equals c squared, plug in the values we know, evaluate the squared terms if we have any, whichever ones we have, we evaluate those, and then solve for the missing variable. Now, important if you need to, we're going to round to 2 decimal places here. So if we have an irrational solution, we'll just go ahead and evaluate that and get a decimal. But let's practice some square roots. So remember, when you take the square root of a number, it equals whatever number multiplied by itself. So the square root of 25 would equal 5, because 5 times 5 is 25. The square root of 100 is 10. And the square root of 19, well, that's not a perfect square, so we're not going to get a whole number. But what we can do is use a calculator, take the square root of 19. It's 4.3 and a lot of stuff. So what we're going to do is round to 2 decimal places. So 4.358 would round to 4.36. Just round that second decimal place based on the next value. Okay, so that's what we're going to do. We're going to do 4 examples, see what we can do here. So example 1a, here we have a right triangle with side lengths of 12 and 9. So remember, we're going to use this formula, a squared plus b squared equals c squared, where a and b are the legs. It doesn't really matter which leg is a and which leg is b. And then c is the hypotenuse, which is the side across from the right angle. So let's fill in what we know. We know, let's say a is 12, so that's 12 squared plus 9 squared equals c squared. And now it's really just a matter of evaluating these numbers. So 12 squared is 144, and you could know that if you use the calculator, just 12 times 12, or 12 squared, 144. 9 squared, that's 9 times 9, that's 81. And so we have to add up 144 and 81, which equals 225. So 225 equals c squared. And now we just take the square root of both sides and c would equal 15. And so if you have a number chart or a squared chart, square root chart, use it, but we need the calculator for the decimal answers anyway, so no harm in using it for all of them. Let's do a few more. Here we have a right triangle that's been kind of turned on its side, but remember, a and b are the 2 legs that make up the right angle. So we know if we have a and b here, and across from the right angle is c. So again, the formula, a squared plus b squared equals c squared. Well, we're missing a here, so we're going to leave that a squared. But we know b is 3, so 3 squared, and c is 4. So a squared plus 9 equals 16. 3 squared is 9, and 4 squared is 16. And now we solve. Subtract 9. So a squared equals 7. And now we take the square root. So we will get an irrational answer here. The square root of 7 is 2.64575, and so on. So we just round that to 2 decimal places. 2.6, and because the number following the 4 is a 5, we're going to round that up to 6.5. 2.65. Example C. Again, C is the side across from the right angle. So let's say we have A, we're missing B. And again, it doesn't matter which one you make A and B. You could do this A and this B. A and B are just the legs. They are interchangeable. So A squared would be 3 squared plus B squared equals C squared is 5 squared. So that's 9 plus B squared equals 25. And if you subtract 9, we get B squared equals 16. Take the square root, and B equals 4. Last one, 13 and 9. And these are, again, our A and B values. We're missing C here. So A squared plus B squared equals C squared. 9 squared plus 13 squared equals C squared. Well, 9 squared is 81. 13 squared is 169. And if you add those up, it equals 250. Now just take the square root. And the square root of 250 is 15 point, bunch of numbers. So 15.81. We can round it there because the next digit is less than 5, so we leave it alone. 15.81. So there you have it. Quick overview of using the Pythagorean theorem to find missing side lengths of right triangles. A squared plus B squared equals C squared.